Hey everyone, let's tackle problem 1 from the roller coaster project. In this video, I'm going to start you off on problem number 1 on each of the parts. We'll do 1A completely. I'll start you off on B, I'll leave part C to you, and then I'll give you a hint for part D. So you can pause right now to read the prompt if you haven't already. And you can note a couple of things. Number 1, we have an ascent of slope 0.8. and a slope of negative 1.6 for the drop. We also have 3 different pieces to our roller coaster, L1, L2, and F. Now I'm going to call F big F. Change that lowercase f to a capital. I think the functions should be uppercase and the coefficients and the variable x should be lowercase. This is personal preference. It's not like the book was wrong for doing this, but I think it's just better notation, and I would like you to do this as well. Actually, the last piece of information is that the distance between P and Q is 100 feet. Okay, I'm just going to highlight those little bits of information. Now, anyway, we want to graph these functions. We want to figure out what L1, F, and L2 are, and we want to graph them. So just to give you an idea of where these functions are, if I were to draw a set of axes, right, that's where they are. Right? This is the x-axis, this is the y-axis. P is the origin. Right? They mention this. And they also mention that Q is 100 feet away. So we have that, right? And I'm just going to write over L1 in red ink. F was green. And L2 is going to be blue, just for the ease of notation. So just to be crystal clear, we have L1 of x is defined to be m1x plus b1, right? It's a line. Now, if you're clever, then maybe you already know what b1 equals, but if not, then just hang on a sec. Big F of x, remember we're calling it big F, is ax squared plus bx plus c. And then lastly, we have that L2 of x equals m2x plus b2. So what we're going to do, just to be formal about this, is we're going to take L1, F, and L2 and combine them all into a piecewise function. I'll call this script R. So R of x is going to equal what? Well, it's going to be L1 of x for x less than or equal to 0, F of x for x between 0 and 100, and L2 of x for x greater than or equal to 100. So that's going to be m1x plus b1, that's a comma, for x less than or equal to 0. It's going to be f of x, right? It's going to be ax squared plus bx plus c for x between 0 and 100. And it's going to be m2x plus b2 for x greater than or equal to 100. Now, in case you're saying, wait a minute, you just overlapped your pieces, right? You had L1 of 0 and F of 0. They're both defined, for x equals 0. That's okay because we're going to let L1 of 0 equal F of 0. We're going to let F of 100 equal L2 of 100. So it is okay that we're overlapping like this. All right. Now let's dive into problem 1 that we have the structure set up. For 1A, right, again, we're supposing it's 100 feet. Write equations in A, B, and C that will ensure the track is smooth at the transition points. We're going to write 4 equations, 2 of which I just mentioned, and 2 of which maybe you can guess if we want to be smooth, right? The key word here is smooth. Maybe I'll use a blue highlighter for this. Right. So here are the four equations. Number one, we want L1 and F to meet at P. So our first equation is going to be, let L1 of 0 equal F of 0. We also want the roller coaster to be smooth, right? So it's not just going to do something awkward like that, right? The line awkwardly transitions to the parabola. We need it to be smooth, right? So our second equation is going to be L1 prime of 0 equals F prime of 0. Okay, that's equation 2. Now, I guess I should back up for 1 second. For equation 1, we actually know another little piece of information. We also know that because P is at the origin, or P is the origin, I should say, that L1 equals of 0 equals F of 0, which equals 0. I should back up. Equation on number 3. Now, you might think it's going to be, oh, okay, well, let F of 100 equal L2 of 100, right, because we want them to meet. That is correct, but it turns out that when you solve for this stuff, it's actually easier to first say F prime of 100 equals L2 prime of 100. It just works that way. And then last but not least, equation 4, F of 100 equals L2 of 100. Okay. So I know it's a little bit, it's not quite nice. You'd like to do L1, L1 prime, F prime, but it turns out this is the way to do it so that you can solve for your variables. So your job is then to write out the equations and more explicitly and solve for them. And we're going to do that right now in for part B. For part B, to solve the equations for A, B, and C, and find a formula for f of x, let's also find m1, b1, m2, and b2. So first, let's actually put in a step 0. Step 0 says, note that m1 equals 0.8, and M2 equals negative 1.6, right? That was based off of that highlighted stuff. Okay? So we get that for free. Now we go to step 1, equation 1, right? L1 of 0 equals F of 0. Well, what's that the same thing as saying? Well, that's the same thing as saying, right? This means equivalent to saying, well, let's see, L1 of 0 is going to equal, actually, I should do it down here. L1 of 0, let's see what that equals. That's, I guess that's 0.8 times 0 plus B1 equals A times 0 squared plus B times 0 plus C. But remember, actually, we also know that that equals 0. So this equals 0. Well, when you simplify stuff out, right, multiplying by 0 just gives you 0 again. This results in B1 equals C equals 0. Well, that's great. We already found B1 and C. So we actually already found L1. Okay? So right off the bat, we know that L1 of x equals 0.8x, right? Because B1 is 0, right? M1 is 0.8, B1 is 0. Okay, and I guess we also know a little bit more about f. Big F of x equals ax squared plus bx, and then plus 0, right? Because c equals 0. Okay. We also know L2 equals negative 1.6x plus B2, but we don't need to worry about that right now. Okay. So for, let's see, for the other stuff, just note that for equation 2, L1 prime of 0 equals F prime of 0. will allow you to solve for B. For the third equation, f prime of 100 equals L2 prime of 100 will allow you to solve for A. And then the last equation is that f of 100 equals L2 of 100. Again, we're not going to do any of these out. I'm leaving that to you. But you'll be able to solve for B2. There are some decimal answers. B2 is a pretty nice answer, just to let you know. Okay? So that's how you do part B. Maybe let's just close that off. Just a quick note. For part C, I'll just say, actually, maybe I'll just put part, actually, I can erase these. For part C, I'll just say use Desmos or Mathematica, but I'll just say use a computer software after you find part B answers to graph your solutions. And then for part D, you need to find the difference in elevation between P and Q. And I'll say the hint is that P equals 0, 0, and Q equals 100, comma, maybe I'll put this down here. Q equals 100, comma, f of 100. Or, if you prefer, L of 100. Okay? So, those are our 4 parts to number 1. So, as you see, I didn't do it all for you, but I started you off. So, from there, the most important part is B. If you solve B, you get everything else.